Manny Jaman, Principal Architect at H&R Block.
Hi, I'm Vin Kamath, Principal Architect at H&R Block, and today we're going to talk about Azure Cosmos DB as the backbone for AI-enabled enterprise applications. We'll get started with Manny talking about the journey we've had so far. Go ahead, Manny.
So if you really look at H&R Block, well, H&R Block is in tax business since 1955. In the world of distributed and cloud computing, we took a journey to modernize our tax platform about 3 years ago. The idea was to provide H&R Block clients an omnichannel service by composing the applications on a single platform. So as we tried to do that, we set two big goals. Number one is being entirely cloud native. We didn't want a lift and shift or infrastructure as a service. We wanted to build from ground cloud native. And the second piece of this was to have a clearly defined bounded context following domain driven design. And we wanted to extend that all the way to the data. So with those goals in mind, we looked at the technology landscape. And what we found that as, a, as an architectural choice, we landed on doing microservices for the clear isolations and independence. And to extend that isolations all the way to the data, we chose Azure Cosmos DB as our storage, as opposed to a traditional RDBMS. So let's look at the journey. When you look at the journey, we with set out with some big positives. With Cosmos, that doesn't really have a schema, we are able to learn and adopt to the data model as we took the journey. Meaning, we didn't have to wait all the way for all the requirements to be known. We just started going as soon as the information was available to us and adopt to the changes. So this feature also allowed our developers to focus on the capabilities that they are offering and not have to wait for the others because there was continuous adjustment. This was one of the greatest features that we had as we were developing these applications. The second piece of this, which was very important to us, is H&R Block is in a tax business which is seasonal, meaning January to April. So we don't really have that much going on in terms of load of clients rest of the time. Even during the tax season, we really have two big picks. So what we really wanted, a system where we can not only scale out just a compute, but also the data layer. And Cosmos was basically good at it. So we use that to advantage. Then the other big piece was we had transaction systems that were responsible for read and write, and we had other systems like DataOps and other systems that's pretty much doing the read. So we were able to successfully have our read systems like DataOps looking at the secondary region, while our transaction system was completely isolated and not being impacted in the primary region. So the feature of Cosmos that's globally distributed allowed us to do that. Now let's look at some of the opportunities that or the lessons that we learned during our journey. The first one being, even if most tax documents is under 800 meg, we had documents that's about 20 gig, and we found limitations not able to write the document. This is not actually a Cosmos limitation. This is a limitation that the SQL API of Cosmos that we use. So if you were to use Mongo's API or something else, this would work. The other piece of this is the way that Cosmos partitioning works is if you have a document that's more than 3K, then you're kind of the way that we work this out is compress the document nowhere good at it. So no problems there. Now, the scaling down piece that I was referring is the limitations that we ran into, and still it's a limitation, which is, when you're scaling down, you can only scale down to 10% of the maximum throughput you ever have done. So the floor in our case, when we went 10% down, that was more than what we need in the off season. So, but that's the way it works. So not bad there. Um, then the final piece of this that I like to call out is a clear understanding about how the consistency model works. The consistency models, there are like five of them. And the highest one is just strong consistency, and the one at the bottom is eventual consistency. We picked up somewhere in the middle, which is a session consistency. Now, the higher the consistency, the more the latency. For our transactional systems, we didn't want much latency, so we didn't pick the first or the top one. What we found though is, when we're writing data and another service is actually trying to look for the data we just written, we couldn't find it. So the way that we found and figured this out is we used a client session ID that we share, and we were able to work around with that, and it worked. So overall, the experience with Azure Cosmos DB was great. This is our third year, and we have been doing really, really good. So with that, I will let Vin go over with some of our uh, journey in the AI space.
Awesome. Thanks, Manny. Um, Glad you girls could join us today. I would just like to start off with uh, starting with our journey in the AI enabled app space. This is going to be a fast paced session here, have limited time, but I do want to talk about our journey as we first started to get into the generative AI space. For HRB customers, we developed and launched almost 2 years ago now AI Tax Assist, which is a capability that lets our DIY clients ask tax related questions, product related questions, and get quick answers 24 by 7. This was a important piece that evolved our help center capability into something that is interactive, and I'll speak to how that works in a little bit. We also developed and rolled out in production self-help capability for our tax pros to help them with technical and tax prep related issues that are that may provide them a summary of resolutions. We also did a whole bunch of applied AI experiments, and there are several that are on the roadmap. For HRB Associates, we also built and launched probably more than like somewhere around the same time when we did AI Tax Assist, a private, secure ChatGPT app that uses Azure OpenAI service. We also did multiple tooling experiments with AI, such as building testing and evaluation capabilities so that the manual testers can evaluate them. All of this experience prepares us really well for what's to come in the years in the future. Let's get back to AI Tax Assist. So we went from a search, primarily a search experience, to an AI infused conversational experience. So if you look at how we used to do in the past, and this still exists, but if you want to ask a question, how to claim adoption credit, you would get a whole bunch of questions and you have to sift through them, see where the answer is, or use our online virtual assistant, which has pre-canned questions. From there, we went to this, where you can ask a question and get a response immediately. Now, it also has chat history and a whole bunch of other capabilities, including follow up questions, which are pretty handy. All of this was done over a record period of time, rapid application development, rapid iteration. And all of that was possible because we didn't have to worry too much about our persistence layer, which is where Azure Cosmos DB comes in. I'll just quickly go through tech stack. Usual suspects here. we are on the .NET and Azure stack. Cosmos DB Azure storage integration was really simple considering the Azure SDKs that were available to us. And infrastructure, Azure OpenAI service, Cosmos DB, SignalR, App Gateway, all of the usual suspects, like I said. All of this enabled us to, develop and deploy this in record time. And it also allowed us an incremental uplift in client satisfaction and conversion. So this has been in production for two tax seasons now, including this one. If you look at this high level conceptual architecture diagram, on the right hand side, you see design time capabilities that we have built from multiple content sources, including our tax institute, which is proprietary content that we process and ingest. We have content ingestion pipelines that enable us to push it to Azure Blob Storage. We have a content indexing service that uses the embedding model from OpenAI, and we prepare a index in the Azure AI search. So in runtime, as the user queries come in, we use Semantic Kernel, SDK, and then we run the query, embed it. We search the query, we do the retrieval part of the RAG pattern, and then we do the generation part of the RAG pattern. So the assembled custom prompt is what is finally being sent to the GPT model, GPT-4o model is what we are using. So if you look at this is a pretty simple high-level diagram. But if you unpack this, there are so many capabilities that need to be built, including the evaluation pieces. And all of that data, where is it stored? It's stored in Cosmos DB. So why did we pick Cosmos DB? One of the number one reasons why we picked it is because developer productivity. It all depends on what is your custom stack that is familiar to the developers and the team. And with your stack being on Azure and .NET, it was just a no-brainer. The schema-less rapid app development also helped us tremendously. Obviously, Manny talked about scalability, regional replication, etc. So once you have Cosmos DB, what are the kind of things that you can use it for, right? So all of these are, this is data that you can store in Cosmos DB, and eventually being able to run vector search on it, semantic search on it, etc. So what happens is once you have data, the vectors can stay close to it. Today we use Azure AI Search, but for several other experiments and on the roadmap, you can think about what's possible. So this is why I spent a little bit of time developing a demo of answering that question as to what is possible when we use Cosmos DB. With that, we'll get into a quick demo. And in the demo, we're going to explore what I call functional observability. So this is not your typical infrastructure observability or your app observability. This is about data. So if you have data and you want to run analytics, there are so many ways to do it, right? So one of the questions I asked myself is, what if we could use AI to do this? So I'll quickly switch to the demo here. So with Chat's transcript analytics, what I did is I created a bunch of educational sample data for conversations that could happen between a tax assistant, an AI tax assistant, and customer or the user, right? So if you look at this, this is all sample data, simulated synthetic data, and this is just an explorer of that data. So a user can ask, can you tell me what the federal tax filing deadline is? And assistant comes out back with a response. And again, like I said, none of this is from our real data. This is synthetic data that we use to test possible hypotheses of how we can improve our experience. So I'll go through a few more. You can see how I've generated about 20 of them, I believe. variety of questions. Some express frustration, some are annoyed, some are really happy. It all depends. So all of this data is stored in a chat transcript DB. So if you look here, this is a very simple data model for the chat transcripts. Role is the user, assistant says this, so on and so forth. And down here, you can see the embeddings of the conversation. So these are, you can go look at and Google it a little bit and see what are embeddings. But you can literally ask questions that are semantically similar to extract information. This is the retrieval part. In order to do that, you have to generate embeddings using one of the embedding models. So I can go through some additional chat transcripts here, but you get the idea, right? Now let's switch back to the app and I'll show you what the goal is here. So the goal is to generate something like this. I want to run analysis on this chat transcript data. So when I run the analysis, I've run some analysis already. I've sampled the data because running, if you have millions of transcripts, running all of them becomes very challenging and takes a lot of time. So I've sampled the data to be able to demonstrate and showcase what's possible. So in this case, I'll zoom it a little bit. You can see I've analyzed 10 transcripts. The overall sentiment was neutral for this sample. The top topic was home office reduction. What were the common pain points? I want to know that, right? So this app uses generative AI, specifically the O3 mini model, which is better at reasoning, is used to decide, given this transcript messages and bunch of transcripts, in this case 10, how can we extract this information that we are really looking for? Why are we doing this? To improve the experience, right? To find out what we can do to make it better. So we have sentiment analysis here, we have popular topics, user expectations. What are users actually expecting out of this interaction? What are some key insights, right? So I can go back and look at some older ones and see what were the common pain points, popular topics, because this helps us. If we know what the popular topics are, we can spend more time improving that content. Now, I didn't stop here because this is a good readout. I'll quickly show you how that works. So if I click in-depth analysis, it's going to pick up 10 transcripts and start to analyze each of those individual transcripts and create analytics for that transcript. And once you have a bunch of analytics, it puts them all together and goes to the next step, which is to aggregate the results of that analysis and eventually generate final insights, save results, and present that information. That's what we saw in the dashboard panel earlier. We also have some analytics about what was the average messages per conversation, what was the duration of the conversation, how long they were on, things like that. So this is really helpful for us to understand how things are working in when you have an AI assistant experience. Now, this may be enough, but what if I have more questions about this, right? What would I do? Well, for that, we have a chat assistant. So this is a little bit of meta because you have chat transcripts and you want to chat about those chat transcripts, right? So here are some examples. So I can click on one of these and ask this question. Provide me an analysis of the questions about IRA benefits, please. So one of the goals with this demo was to build a semantic kernel and generative AI capability to act like an autonomous agent who is entirely analyzing the question. What kind of data do I need to answer that question? Go ahead and do the data gathering piece, review, and so on and so forth. And if I expand this, I can see how things are happening, right? So each step is producing what is going on under the hood. And you can see these are tools that are available to the system. Sorry, it's still working on it. So the expand collapse is happening. But I'll show you what happens in the end. In the end, I get an analysis of, okay, depending on the question, IRA benefits was the question, the volume, right? What is the thematic frequency, time trends, message distribution? All of this is planned in these earlier steps. Okay. And we are using the Cosmos DB vector search capability to ask those questions. I'll quickly run through the code for you to see it. But you can see all of these steps are autonomously occurring, that the agent is taking place. So the agent is deciding, how do I decide how to answer this question? What kind of data do I need? What kind of tools I have at my disposal in order to answer the question? So eventually, even after it gathers the data, it formulates a response that is meaningful, right? So if you look at the insight generation step, okay, below are the three key insights, and then clarification, planned use of vector search that happened. So I made it very elaborate here for technical audience so that you can see how some of the kernel plugins functions are being called here. Let me jump back to the code real quick. I'll quickly go through two projects here in this solution. The first one is the transcript generator. So I have a simple system prompt that was able to generate those educational examples. I have a example JSON structure that I provided. And I have a Cosmos DB service that's able to upload the transcript, set up indexing policy, vector indices, stuff that we talked about. I'm using disk ANN, which is a newer capability that was released late last year. It's best for performance and scalability if you have more than 1,000 vectors. We are using the cosine similarity here. The dimensions are 3072 using the text embedding 3 large model. Now let me quickly switch back to the app. So in the app, what's actually happening is we have two semantic kernel plugins, and each of them provide a bunch of capabilities. Get conversation stats, get message distribution async, conversation time metrics, get interaction patterns. We have a vector search plugin that is able to do search similar transcripts, so on and so forth. So if I switch back to the Cosmos DB interface here, during the analysis, we produced these comprehensive analysis that we earlier saw, right? So the first step was to create these analytics and embed them. And the second step was to aggregate them, which is what we did. So in the runs, that's what you saw. Things like, okay, what were the pain points, confusion over eligibility, right? So this was aggregated analytics. All of this was created by the application using these tools and functions. Now I'll go over some of the prompts of the agent. So starting with this chat agent service, as the request comes in, again, using SignalR, we are able to use the chat hub. So in the chat hub, this is where the entry point of the message is once the message comes in. So we start a step, right? We start step-by-step process and send out what we call as the reasoning transparency. In order to provide transparency to the user as to what is happening, you have to notify the client. In this case, it's the user. So this chat agent service eventually ends up using step-by-step actions, right, in order to execute what the user query is and how to find an answer for. So all of this, if you look at the evolution of from here, what you can do, you can put this into a loop. So until you have a final response, you are looping through the analysis phase, the planning phase, and the final response generations phase. All of that is happening using the Cosmos DB query plugin and the Cosmos DB vector search plugin. When all of these are put together, you can imagine if you put the data from Cosmos DB and the AI using the Azure OpenAI service generative AI models, what actually is possible, right? You can have this run every night, for example, do its sampling, improve the accuracy of the generated analytics, and make informed decisions to improve the experience for the user. And this is not domain specific, to be honest with you. If you think about this, this can be applied to any kind of data that exists in your Cosmos DB. Any JSON document, structured or unstructured data, can be analyzed on when you put AI and data together. Thank you. Hope you had a good time with our session here. And I expect you go back and um, experiment with how to put data and AI together. But before you go, I do want to uh, highlight that today is April 15th, right? It's a tax day. If you haven't yet filed your taxes, file it with H&R Block. And you can file it however you want, from home, in person, or drop off. Multiple options available. We also have a mobile banking platform called Spruce. Feel free to check it out. See you next time. Thank you.
Thank you guys for watching us. Reach out to us. This has been a great experience using Azure Cosmos DB, modernizing our platform. Thank you.